ready? You ready? You ready? We're looking at the limit as x goes to infinity of the quantity square root 9x squared plus 3 minus 3x. Oh no! ¿Qué vas a hacer? What are you going to do? Well, if we run the limit directly, it looks like we have infinity minus infinity. And you're like, that's got to be 0. But not necessarily. You don't know how big your infinities are. Aren't they all the same size? Well, kind of. Anyways, we'll go into that in a moment. Let's just complete this vid. What do I want to do? I want to multiply top and bottom by the conjugate y so that I could use this guy. The difference of squares. What's that going to do? It's going to rid us of roots. After we do that, we're going to be left with a situation where we can use that guy. The limit, as the denominator gets big, goes to nothing. So, let's go ahead and try our algebra now. On this guy, I've rewritten the thing that you're taking the limit on. This is over on the side. Oh, this stylus works so much better. I'm going to rush out and get one. So then, boom, we're going to multiply by that conjugate. That's the square root of 9x squared plus x. Whoa, get over there. Boom. And then plus 3x. Oh, no. Oh, no. Scratch. That's the square root of 9x squared plus x minus 3x times 9x squared plus x. That was the root. What changes? The sign in between the two terms. Plus 3x. I had to go to a different slide because I ran out of room. I can't just multiply the numerator. I need to multiply by the magic one. If I can multiply once, then I can multiply twice. When I'm talking about the magic one, I'm saying, what's 5 over 5? What's 10 over 10? What's a million over a million? What's the square root of 9x squared plus x plus 3x over the square root of 9x squared plus x plus 3? Okay, so we're just multiplying by 1. We're not trying to change a dang thing. We're just trying to make it look different. I'm different. So then, we're using the difference of squares. There I have something minus something times something plus that very same something. We're going to get the square of each term. So that's 9. That's the square root of 9x squared plus x. Shorten that up. Squared minus 3x squared all over that square root of 9x squared plus x plus 3. We multiply that out there, see? And look at the nice numbered world you live in.
Should it be plus 3x?
Wasn't done. Didn't take my hand off it. Thank you. That's 9x squared plus x minus 9x x. I'm out of room. There should be an x here, this part. 9x squared minus all over that square root of 9. It's interesting. X squared plus x plus 3x. This will get better, but what do I want to do? I want to kill these guys. Oh! So now follow me onto the next page. What did I have left over in the numerator? X alone. And then in the denominator I had the square root of 9x squared. Was it plus 3x? And then plus what?
No, plus x. And it's just plus 3x.
Inside the square root, it's just x.
And then plus 3x on the side.
Plus x? Pink. And then plus 3x?
Yeah.
Okay, I'm glad this happened. You're like, how am I going to be able to use this? Well, we have to do some more algebra. You did pick dirty. How about we factor out an x from that denominator so that we can get some reduction? You say, what? I'm saying factor an x out of that denominator. Then you're going to be left with the square root of 9. Oh, I did it again. I feel like Brittany. I'm going to run out of room. That's 9x squared plus x divided by x plus 3. Whoa! What happened? What happened? I went and I pulled an x out of that denominator. Notice, if you distribute in there, do you get the same thing? Because the x's are going to reduce in this first term, and then that x is going to go to the 3. Did I get the same thing? All right. More trickery. More trickery. Can I reduce these x's here?
Yep.
Yeah? Yeah. So that'll be a 1 and that'll be a 1. Okay. That's not the trickery I'm talking about. This is. Ready? 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 Focus on this piece. Here's how it's going to change. It's going to become a big root. And then this is 9x squared over x squared plus x over x squared. Wait a minute, what happened? I put this root inside that I put that x inside the radicand. That's why I had to make it x squared. The square root of x squared is just going to be x. But I snuck it up in there. And I snuck it up under both of those terms. And then I'm still going to have the rest of this stuff. So that was the thing that you were focusing on. I put that x inside the root. Trickery. That's 1 over this plus 3. How's that working for you? Now I know this is getting a little long, but there's a lot going on. Now I'm going to reduce. So that's 1 over, that's the square root of 9 plus 1 over x. And then plus 3. I ran out of room again. That should be a plus 3. Okay. So what? We have that. This guy, after manipulation, turns into this guy. So we have that limit, that guy, that's going to be equal to the limit as x goes to infinity of 1 over the square root of 9 plus 1 over x plus 3. Is that right? This one was dirty. So then we run that limit. The root is continuous on the positive x's, so we can pass the limit inside the root. The limit as x goes to infinity of 9. That's 9. What's the limit as x goes to infinity of 1 over x? That one goes to 0. So then after we run that limit, we're going to end up with 1 over the square root of 9 plus 3. That's what? 1 over 6. So in this scenario, what? Infinity minus infinity happened to be 1 over 6. Box and flower. What questions? Yeah.
How'd you get the 9x squared over x squared?
The 9x squared over x squared?
Yeah. On the root.
In the root?
Yeah.
This part?
The bottom left.
Yeah. So this part? The